So let's use what we learned in the last podcast and put it into play here. I've got two examples for you. I'll do one in one podcast and one in the next, just to keep the podcast a little bit smaller. All right, here we go. So if you look at example 3 here, it says, describe how the graphs of the following functions relate to the graph of y equals to f of x. Well, take a look at what we did here. If we used replacement notation, did I not take this x and make it to an x minus 5? There you go, replacement notation. You're done. That's how easy replacement notation is. But now, remember what this means. This 5 here means that this is an h value of h equaling to 5, right? Okay, it's not the same as the replacement notation. Very important. H is actually 5. And what does this mean? That means I moved 5 right. Okay? Because it's a positive value for 5. Case in point, look at the very next question right here. Look what happened here. If I used replacement, look what I did. I replaced the y with y minus 3, which, if you think about it, is a k value, and the k value, in fact, is a positive 3. K value positive 3 means I moved up 3 units. Aha! Let's look at the last one, right? Look at this. Mapping notation said x is, or I should say replacement notation, not mapping notation. Replacement notation says I've taken the x, I replaced it with x minus 7. I've taken the y, I've replaced this with y plus 2. There's your replacement notation. But what does this mean? In order to change this from a negative to a positive, this k value must have been negative to begin with. Okay? Notice how this is still a negative value, so that means that the h value is got to be a positive 7, which means that I moved right 7, down 2. Value is negative and a positive. Let's leave it at that. I'll do example 4 in the next podcast.